Hello everyone, welcome to Coders Camp, and we are at 18th day of April LeetCode challenge, and the problem we are going to cover today is remove nth node from end of the list. So the input given here is the head of a linked list and an integer value n, and we have to return again the head of the linked list after removing the nth node from the last of the list. So let's understand this problem with an example. So here is a given input list with values 1, 2, 3, 4, 5 and an integer value n is equal to 2. So we have to remove the nth node from the last of the list. So here the nth node from the last is going to be 4 because this is the last node, this is the first node from last, and 4 is the second node from last. So after removing the fourth node, the output is going to look like this, and this is the output we are going to return. So how are we going to approach this? So we are going to see two different solutions for this problem today in this video. The first solution is a two-pass solution and the second solution is a single pass solution. So let's dive in. So here is our given input list with nodes 1, 2, 3, 4, 5. So first we are going to iterate through the list to find the length of the list. So here the length is equal to 5 as there are 5 nodes in the given list. So now we are going to subtract n from the given length so that the length becomes 3. So 3 actually denotes where is our node to be deleted from the starting of the list. So for example, here n is equal to 2, so we subtracted 2 from 5, which means it points at the node exactly where the next node need to be deleted. So once we found the length is equal to 3, so once we find where we need to delete our node, we are going to again iterate through the new found length. Once we iterated till the node we want, we are going to point that nodes next to next dot next, so that the node in the middle is going to be removed or deleted, and further we link it to the next node occurred in the list, so that the node will be removed and we are going to return the result as the head of the list. So this is going to take two pass solution. The first pass we are going to iterate through the given list, which is going to take the number of nodes, list nodes given, and at second pass we are going to iterate till n minus l times. So overall the time complexity is going to be big O of l, where l is the number of list nodes given in the input. So let's see the code now. So let's start by declaring the variable length is equal to 0. So now I'm gonna iterate through my given list in order to find the length of the list. So once my length is updated, I'm going to check the basic conditions that the given n is greater than the length of the list. Then simply we are going to return the same list as given. And if the length is equal to the given number n, then so we are going to simply return the head dot next. So if not, we are going to subtract our n from length and again iterate the given list for that length. To do that, I'm going to check whether my length is greater than 1 and it did not reach the end of the list. Then I'm going to iterate my dummy variable or dummy head till that node. So once I iterated till that node, I'm going to connect my dummy dot next is equal to dummy dot next not next, so that the middle node between dummy dot next and dummy dot next dot next will be removed, and finally return the result. So yes, coding is done. So let's run. Yes, so let's submit. Yes, our solution is accepted and it runs in 0 millisecond. So yes, let's move to our next solution now. So our second approach is going to be a one pass solution where we are going to have two pointers, slow and fast. So first, our slow pointer is going to be placed at before a dummy node of our list, and our fast pointer is going to point m nodes away from the slow node. And once we placed exactly the fast and slow, we are going to iterate each node at a time. So once we reach the end of the node by fast pointer, our slow pointer points at the node where we have to delete the next node in the list. So when we placed our slow pointer at the correct node we want, we are going to place that node's next to its next dot next. So that as per the same logic as the previous solution, we are going to remove the required node and return the result. So as this solution is gonna iterate only once with slow and fast pointers, our algorithm works in big O of L time, where L is the number of list nodes given in the input. So let's go to the code now. So yes, let's start the solution for our second approach, where we are going to declare a dummy head with 0 as its value, so that our slow pointer starts at the dummy head. And I'm going to declare my two pointers slow and fast, starting from the dummy head. So I'm going to iterate and place my fast pointer n nodes away from the slow pointer. So I'm going to iterate my fast pointer and place it exactly n nodes away from the slow pointer. So once I placed my fast pointer n nodes away from the slow pointer, I am going to iterate both my fast as well as slow pointer by one node at a time. So once both the nodes or both the pointers have been placed, we now know our slow pointer dot next is the node we want to delete. So we are going to assign slow dot next is equal to slow dot next dot next. So once it is assigned, our node is deleted. So we are going to return our dummy head as our result. So let's run. Yes, so let's submit. So this solution is accepted as well. And this also runs in 0 millisecond. So thanks for watching the video. Hope you liked it. If you like it, hit like and subscribe and let me know in comments. Thank you.